Right, so today we're going to talk about rational exponents. We're going to learn how to write a radical expression as an exponential expression and vice versa, and we're going to learn how to simplify an exponential expression with radical exponents. So you can take a second to read that, but I want you to notice that this becomes my numerator and the index becomes my denominator when I'm rewriting a rational exponent. So if I'm going to rewrite, because it's negative, we're going to bring this to the bottom, so negative 2/3. Then the 3 becomes the index, and the 2 is the exponent on the W. Okay. X to the 1/4. 1/4 is equivalent to 1 4/10 is equivalent to 7/5. So this becomes the 5th root of x to the 7th. And if we wanted to simplify that, remember I've got, this is the same as x to the 5th times x squared. So I've got an x that comes out to the 5th root of x squared. In this example, we're going to go the other way, so I get that on my fraction, the 3 is the numerator, the 4 is my denominator, so x to the 3/4. On this example, x to the 5/6. If I'm going to simplify here, I'm going to get 32 to the 4/5. And p to the 15 times 4/5, and I'm going to use exponent rules to solve. So I'm going to multiply my exponents here, so 15/5 reduces to 3, so this becomes 3 to the 12th. And this becomes the 5th root of 32 to the 4th. Now 32 is just 2 to the 5th. So this can be rewritten as 2 to the 5th 4 times. And remember, when I pull out groups of 5, they become 1. So on the outside, I'm going to have 4 groups of that 2. So 2 to the 4th times the 5th root of nothing. So times p to the 12th, or 16p to the 12th. In this case, x to the 4th to the 2/3 becomes the 2nd root of x to the 12th, okay, which would just be x to the 6th because there's 6 groups, or we don't even need to do that. We can do 4 times 3/2, and 4 times 3 is 12 divided by 2 is 6. So x to the 6th. In this case, it becomes the 5th root of negative 32 to the 6th. So I've got 5 groups of 32 that are going to come out, and I'm going to get 32 times the 5th root of negative 32, and it's a 5th root, so we're going to pull out this negative. We're going to leave that as a positive inside, and then we said that 32 is just 2 to the 5th from the first problem, so that becomes negative 32 times 2, or negative 64. So just a review, here is all of your laws of exponents, and we use those to simplify. Okay, so I'm going to change this to 6 to the 1/4 times 6 to the 1/3. Makes it a lot easier. If I add my exponents, 1/4 plus 1/3 is 7/12. So this is 6 to the 1/4 plus 1/3, which is 6 to the 7/12. 12th. In this case, if I can, this is going to be x to the 4th y to the 1/2 over x squared y to the 8th over 1/2, or 1/4. So now I'm going to use my law of exponents, and I'm going to multiply in. So I'm going to get y. 4 times 1/2 is 2, and then y to the 1/2. Okay, if I bring in the 1/4, 2 times 1/4, sorry, that should have been an x. 2 times 1/4 is 1/2, so x to the 1/2, and then y squared. Remember from algebra that we're going to subtract exponents this time, and it goes with the highest power. So 2 minus 1/2 is 4/2 minus 1/2, so it's 3/2. So I get x to the 3/2 on top, y to the 3/2 on bottom, okay, which is the same as the square root of x cubed, the square root of y cubed. Sorry, I ran out of space, wasn't thinking this through very well. So I get x times the square root of x over y times the square root of y. Okay. Again, in this case, we're going to take our power inside. So I'm going to do negative 27 to the 1/3, which is the cube root of negative 27, which is negative 3. And then x to the negative 9 times 1/3 will be x to the negative 3. And I don't like those negative exponents, so negative 3x cubed. Right, in this example, I'm just going to bring my 15s inside by multiplying, taking the power to the power. So 15 divided by 3 is 5, so I get x to the negative 10th over y to the negative 5th, and then I just flip them, so I get y to the 5th over x to the 10th. Okay, so today we looked at how to write a radical expression in exponential form and vice versa, and then how to simplify. So have a math-tastic day.